Hey everybody, today we're going to be talking about lesson 5.8, analyzing graphs of polynomial functions. And the first thing I want to do is remind you of some vocabulary terms. Anytime I use the terms root, zero, x-intercept, or solution, those all mean the same thing. Those are the answers to our polynomial functions, and it's where the function crosses the x-axis. Remember that whenever we're doing synthetic division, that is the k value that we are talking about, because our factors are x minus k. So if x minus k is a factor, then that means that k is a solution to our polynomial. So we are going to use the x-intercepts of our graph in order to graph some polynomial functions first. So the steps for doing that are identifying the x-intercepts and plotting them, and then determining the end behavior from our degree and lead coefficient. And I want to point out something here. Our degree is going to be adding up all of the factors, because some of them may be repeated, some of them are single, but each of them will contribute to a solution or an x-intercept. And then finally, we can draw the graph. So let's take a look at what that looks like for this first example. If we have f of x is equal to 1/6 of x plus 3 and then x minus 2 squared. Now the one thing that I notice here is that I have a squared, and if you want to go ahead and designate it here, this x plus 3 is to the first power. That way I know when I add up all my factors, I have 1 and then 2 makes 3. So let's do A, which is identifying our x-intercepts. So we will have x-intercepts at x equals -3 and x equals a positive 2. Remember that intercepts or solutions and factors are opposites of each other because of the x minus k in our factor expression. So we can plot those 2 points at -3 and at 2. And you might want to also make yourself a note that the 2 is a repeated solution. I know that because I have a 2 here. It happens twice. Let's go ahead and identify our degree and our leading coefficient now. So for degree, as I mentioned, we're going to add up all the factors. We don't have this polynomial expanded into standard form. It's in factored form, but we can still figure out the degree by looking at how many factors we have. We have x plus 3 as a factor and x minus 2 as a factor, but x minus 2 happens twice, so 1, 2, 3. 1/6 is just a coefficient. It is not a factor. So our degree is 3. And remember that we want to say odd or even, and degree is odd for 3. My lead coefficient is that 1/6, and that's positive. So this means that my right arrow goes up, and because we're odd, we're opposite, the left arrow goes down. So I can draw an arrow down on the left, up on the right, and then let's fill in, remembering that we need a bounce at 2 because of the repeated solution. I'd like for you to give number 2 a try and then come back here to see how you did. All right, you should have identified your x-intercepts as being at +2 and -3 based on factors of x minus 2 and x plus 3. And note that we have a repeated solution here at x equals -3. The degree is 3, which is odd. I get degree from 1 plus 2, all of the factors that I have. My lead coefficient is a 1/4, which is positive, leading me to say that my arrow on the right is up and on the left is down. So I want my left arrow down, right arrow up, and don't forget that we have a bounce here at -3.